did that.
So here are the answers to last night's homework, and you guys checked all those. Tomorrow's test, here's some of the things that you need to make sure that you understand. It is mostly a test of formulas and doing math with equations. So there are a few questions where you have to take the words and write out the formula, balance the equation, and then do the math with it. There are a few of those on the on the test tomorrow. You need to know the definition of stoichiometry, why it's used, and kind of what the steps are that you go through with stoichiometry. You need to know the law of conservation of mass, which comes up a lot on our test. It will come up again tomorrow. And be able to do these types of problems that we've been doing since last week. My suggestion to you when you study is to make yourself another Notability document with a fresh copy of 11-2 practice problems and do some of those. Do some of the problems on page 378 and 379. And also, if you look through the textbook, go ahead, if you've got your textbook handy, open it up. Some of you never open up your textbook. If you look on page 352, there are some problems in which you have to do the math, and like underneath practice problems on page 352, number one, you have to actually write out the equation and then do the math.
Do they have the answers in the back or something?
They have the answers right underneath the problem.
Are you talking about
Within the book, the answers are right underneath the problem.
I thought you were talking about the practice problems we did, like on page 379.
Those answers are online.
Yeah.
I put them online yesterday. And then on page 357, there's some more problems that you can do, as well as page 360 and page 362. And there's some that are asking you to write out the equation and balance it and then do it. So tomorrow on the test, I will give you a few equations and where I write it out for you, and you just have to balance it and then do the math along with it. Like the quiz, there is a possibility for partial credit. You just have to make sure that you show all your work. Okay? And like the quiz, I will give extra credit if you answer it with the correct number of significant digits.
Can we see the quiz?
Yes. Has everybody in here taken it? The first thing I want to do before I pass back the quiz to Allie is go over any questions that you guys have from this, as well as 11-2 practice problems, and we'll do the quiz last.
Okay.
Judah?
42.
Problem number 42.
Yeah,
On page 378?
Yes, ma'am.
Okay.
C12, H22, row 11, plus 12, O2, goes to 12, CO2, plus 11, H2O.
And you start off with 3 moles of sucrose. And what are you trying to find?
Volume of CO2.
Okay, so you can go from moles of sucrose to moles of another substance. And since we're trying to find the volume of carbon dioxide, before we can find the volume, we need to find what? Where do we always have to go before we can go out?
Moles.
Moles. So always have to go to moles. So we can go from moles of sucrose to moles of carbon dioxide, and then to liters of carbon dioxide. So we start off with 3 moles, and then we're going to use the balanced equation to see the relationship between moles of sucrose and moles of carbon dioxide. And for every 1 mole of sucrose, there are 12 moles of carbon dioxide. And then we can go from 1 mole of carbon dioxide occupies 22.4 liters of carbon dioxide. Now don't forget to cancel out all the units. Take a look at what you're left with and make sure that it's what you're trying to solve for. That's some mistake that a lot of students made earlier. Judy, would you mind? I don't know what I've done with my calculator.
You want me to calculate or do it?
Well, if you'll do it for me. Shelby, would you mind looking on my desk and checking if the calculator needs to work? I've got lots of calculators on my desk, but they don't work.
Okay.
Thank you. There might be one in the bag.
806.4
Okay. 806.4
liters.
liters of carbon dioxide, and 3 moles of glucose has one significant digit. So that means we just want this first digit to be significant. So you could write this as 800 liters or 8 times 10 squared liters.
What's all three of these over?
There's a white bag that's in front of my desk, or behind my desk.
Okay.
Okay, I did the math right and I got 806.4. I just didn't know how you get that to the 8 times.
Oh, okay. All right. Scarlett?
Would you still take 806.4 if it was?
Yes, but if you gave me 800 or 8 times 10 squared, thank you,
You get
then
1 point.
you would get 1 point extra. Blakely?
Number 53.
So potassium carbonate and magnesium nitrate forms potassium nitrate and magnesium carbonate. And we have 549.6 grams of potassium carbonate, and we're trying to find grams of magnesium nitrate. So we can go from grams of potassium carbonate to what?
Oh.
Moles. So I'm just going to write out the pathway here. So grams of potassium carbonate to moles. And then moles of that to moles of magnesium nitrate. And then grams. Is that the pathway you took? I'm thinking maybe your mistake is just simply in the molar mass. So 549.6 grams of potassium carbonate. Nick, what did you get as the molar mass of potassium carbonate?
So, this is 45.
Yes.
53.
What did you say?
It's 53.
53?
No. Oh, yeah. The number is.
138.2.
That's what I must have.
138.2. Is that what everybody else got? If you got it right?
That's right. That's number 10.
And then there's 1-to-1 relationship. What's the molar mass of magnesium nitrate? Chris, what'd you get?
148.3.
You guys in agreement with that?
Yeah.
All right. Is that what you did wrong? Okay. So we're left with grams of magnesium nitrate, and what is the final answer?
590.
Is that rounded or?
Yeah, 589.8.
Okay. 38.2. 589 point.
7.
I got 0.1.
I have 0.8.
Am I wrong?
I have 0.8.
149.6. Oh, I didn't do 0.6. 48.3 divided by 138.2. Okay. So it's 589.8 actually. And we need 4 significant digits, so that is the answer. Yes.
So how would be the best way to plug this into your calculator? Like, would you multiply the entire top row and then divide it by the bottom?
Yes, but if you divide it by the bottom, you need to put parentheses around all the numbers. Or you could say 549 divided by 138 times whatever's on the top, next divided by whatever's on the bottom.
Okay, so it's just if you divide it by the whole bottom side, just put parentheses.
Yes. Mhm. All right. Any others from last night's homework? Judah?
54.
Now, I would recommend that, for example, if you know how to do 54, and you got another one wrong, then while I'm going over 54, you need to go over that one you got wrong and see if you can figure out what you did incorrectly. to make this time profitable for you. So 196.5 grams of aluminum sulfate, and we're trying to find mass of aluminum. So we're going to go from grams of aluminum sulfate to moles of aluminum sulfate. And then moles of aluminum sulfate to moles of aluminum, and then to mass of aluminum. So 196.5 grams of aluminum sulfate. What is the molar mass of aluminum sulfate? Number 54.
I got 246, but I did it wrong.
I got 342.3.
Dahlia, what'd you get?
I got 341.
I got 342.3.
342.3?
Yeah.
So we've got more 342.3s and other stuff. 342.3 grams of aluminum sulfate. And then there's 1 mole to 2 moles. And then 1 mole of aluminum is 27. What'd you do differently?
I got 240 as the mass.
Of aluminum sulfate? So aluminum sulfate has 2 aluminums. It has 3 sulfurs and 12 oxygens. You see why that is?
I think I added 4 and 3
All right. Any others from last night's homework that you want to go over? Grace?
57.
All right, so the first thing you've got to do is write the equation, and this is combustion of a hydrocarbon, so you need oxygen. It's always going to form carbon dioxide and water. And you have 9.88 times 10 to the 21st molecules of hexane. And we're trying to find moles of oxygen. So in order to balance this is the kind of problem where I told you there's step 1, step 2, step 3. What is step 1? Balance what? Balance the carbon. So we're going to put a 6 in front of carbon dioxide to balance the carbon. Step 2 is to balance the hydrogen. So we put a 7 in front of the water to balance the hydrogens. And then step 3 is to balance the oxygen. So we're going to need 12 plus 7. We're going to need 19 oxygens. So what you do is take the number of oxygens that you need and put it over 2 on the reactant side, and that gives you 19 oxygens. Then you can't have a fraction, so you got to get rid of the fraction. In order to do that, multiply everything by 2. So this becomes 2, that becomes 19, this is 12, and the waters become 14. Does that make sense? So we're gonna, yes ma'am.
I think that it was 9.88 molecules.
Sorry, I just saw that. Thank you. All right, so we're going to go from molecules of hexane to moles of hexane, and then to moles of oxygen, and we'll be done. So we have 9.88 times 10 to the 21st molecules of hexane, and we've got to divide that by Avogadro's number to get to moles. And then there are 2 moles for every 19 moles. So this is where the parentheses play a role. Taking Avogadro's number and multiplying it by 2 underneath the number of molecules. So 9.88 times 10 to the 21st. And you do the second E to get the 21st. So we're going to multiply that by 19 and then divide it by Avogadro's number times 2, and Avogadro's number times 2 are in parentheses. And I can't seem to do this myself. And what'd you guys get?
0.16.
Yes, and we need 3 significant digits. So 0.156 moles of oxygen. Grace, what did you do differently?
I just messed up balancing the equation.
Oh, okay. Do you understand how I got the equation balanced? Yes.
So when you're doing significant digits, does a 0 before the decimal count as a, okay.
No, that's just a placeholder. Remember the Atlantic Pacific rule, so the decimal is present. So we're going to travel across the United States, crossing out all zeros until we get to the first non-zero number.
Okay.
Everything past that significant. All right, any other questions?
I just have a question about a rounded number. You put 1.2 and 0.12, and like I did my calculators at 0.125. Would you not round that to 0.13?
For 43?
Yes.
So, yes, it should be 0.13. You're right. So 43 should be 0.13. Let me go back and change that.
Can you just do one of the ones, like how you get the significant digit for, what's it called? I can't remember. Where it's like 8 times 10 over blah, blah, blah. Like, how do you know what 10?
How to do scientific notation?
Yeah, how do you know what the squared part is?
How many places you have to move the decimal? So if this is 800 and you want to just show one significant digit, there's an understood decimal right there. We're going to move it over 2 places, and this is 8 times 10 squared. If you have 0.0080 and you wanted to show 2 significant digits, you could write it like that I have up here. See the one on the right hand side? Or you can write scientific notation by taking that decimal and moving it back 3 places. So this is 8.0 times 10 to the minus 3. So if you have to, if you've got a number that's raised to a negative exponent, that means it's less than 1. If it's a positive exponent, it means it's greater than 1.
So when would we have to do that?
Many times the scientific notation is used to show significant digits.
Okay.
Any other questions? And with really big numbers, like Avogadro's number, you're not going to write out all those zeros. Any other questions from last night's homework? All right, well then let's take a look at the 11-2 practice problems. Yesterday I'd asked you guys to check the answers online in the module for chapter 11 and redo any problems that you got wrong. So hopefully you've had a chance to do that. And does anyone have questions that they still couldn't get done correctly from 1 to 25? Abby?
Number 23, but it was like it had 2 separate answers.
It did. You were trying to find volumes of hydrogen, then you're trying to find volumes of nitrogen. So it asked for 2 separate things.
Oh, I combined it. Okay.
Yeah. Yeah.
Can we do number 9?
Number 9. Probably your issue with number 9 is just not knowing what the equation was. So it is ozone has to decompose into oxygen, and that's simply all that happens. It goes like that, and then you balance it. So this is a 2, and that's a 3. Do I need to do it past that point? Okay. Any other questions on the 11-2 practice problems? What? Yeah, this is 9.
Oh yeah, I put that down.
Are you good with that? Okay, you want to go over the quiz now?
Yeah.
Please.
Alright, so those of you in TV land, I'm going to go over each one of the quiz questions and I'll post the quiz itself online so that you can see it this evening. Alright, so here's number 1. How many grams of iodine are produced when 0.72 moles of fluorine reacts with potassium iodide? So we have fluorine reacting with potassium iodide and it's producing iodine. Now, you don't see any potassium on the product side. So you've got to recognize that this is a single replacement reaction, which means the fluorine and the iodine switch places and it forms potassium fluoride. Potassium has a +1 charge, fluorine is -1, so it's just KF. Does anything look incorrect about the way I've written this? Right, so whenever you have elements by themselves, you always have to ask yourself, are there diatomic elements? Is that element by itself diatomic? If it is, make sure you put the 2 there. So when we do that, then we have to put a 2 in front of potassium iodide and 2 in front of potassium fluoride to balance it. We're trying to find grams of iodine, so we start off with 0.72 moles of fluorine. And since it's already in moles, we can go directly from moles of fluorine to moles of iodine. Now some of you guys missed points because you didn't put the units in your T-chart and the identification of the substance. Make sure you do that tomorrow or you'll miss points again. Now the other most common mistake that people make is when they determine the mass of a diatomic element, they forget to multiply the mass by 2. What is the mass of iodine times 2?
126.
253.
Yeah,
I got it.
253.88 grams.
253.8 grams of iodine. So the mass of iodine is 126.9. You have to multiply that times 2. The most common mistake is people forget to multiply the iodine by 2. And then make sure that you cancel out the units. Here's what I want you to practice doing, because so many people are not solving for the right thing. So when you get done, check the unit that you're left with and ask yourself, is that what they asked for? And they did. So they asked for grams of iodine, and that's what we're going to be leaving off. So 0.72 times 253.8 is 182.7 grams of iodine, and we need 2 significant digits. So it's 180 grams of iodine, or 1.8 times 10 squared grams of iodine. And that's problem number 1 from the quiz. Any questions on that one? All right, number 2. What mass of carbon monoxide must react with oxygen to produce 0.6 grams of carbon dioxide? So we have carbon monoxide, CO, reacts with oxygen, which is diatomic, to produce carbon dioxide, and in order to balance it, we need to put a 2 in front of the carbon monoxide and a 2 in front of carbon dioxide. We start off with 0.69 grams of carbon dioxide, and we need to go to moles.
Question.
Yes, sir.
Why is there not a 4 in front of the O2? Doesn't that balance it out?
If I put a 2 in front of the carbon monoxide, then I have a total of 4 oxygens on the reactant side. And if you put a 2 in front of carbon dioxide, you'll have a total of 4 oxygens.
Oh, I had an extra oxygen on the right somehow.
Oh, this balancing this equation is very frustrating.
The reason why it's probably frustrating is because on the reactant side, you have an odd number because of carbon monoxide. So if you have a side that has an odd number,
I was talking about, sorry, I'm on number 3.
oh, the next one.
Yeah.
Is this supposed to
Well,
be?
what I was saying, if you have an odd number on one side, it's better to even that up before you try to do anything else. All right, so then there are 2 moles of carbon dioxide to every 2 moles of carbon monoxide, and we're trying to find mass, and every 1 mole of carbon monoxide has a mass of 28 grams. right, so remember, cancel out the units, and then check what you're left with and see what you've been asked to find. If you have to, underline it so you don't make that careless mistake. So 0.69 times 2 times 28 divided by, in parentheses, 44 times 2. And this is 0.439 grams of carbon monoxide, and we need 2 significant digits, so that's 0.44 grams. Any questions on number 2? All right, so number 3, there were a couple of big issues with number 3. The first is people forgot how to write the equation or the formula for copper 2 nitrate, and then the other one was they just couldn't get it balanced. And by the way, look at what's going on here. You have nitric acid reacting with copper metal to produce copper 2 nitrate, water, and nitrogen dioxide. Where did you see that reaction? In the lab. Right, so the first day with a piece of copper wire, we poured nitric acid in there, and we actually did a problem with this reaction.
Did we balance it?
Yep. So copper 2 nitrate, CuNO3, and there's a 2 there, plus water, plus nitrogen dioxide. All right, so let's just take the balancing portion first. Now, the nitrate group is not the very same on both sides because you do have nitrogen and oxygen by itself, so we're going to count that separately.
I'm stuck with an 18 and 17 right now. It's just really killing me.
6, 7, 8, 9. All right, so we just have to get started somewhere. What would you like to do?
What's the easiest place to start?
Wait a second.
So much what you're doing is totally wrong.
Isn't there
It's hard.
supposed to be 3 ends on the right side? Because there's the nitrogen dioxide in.
Oh yeah, there's supposed to be 3. Yeah. Thank you.
It's impossible.
It's not impossible.
Possible.
Start with H.
Okay, so what do you want to do with hydrogen?
It's put 2 on the left.
A 2 in front of the nitric acid? Okay, so when you do that, I meant to change colors. So that means hydrogen is now at 2, nitrogen is at 2, and oxygen is at 6. Our oxygens aren't quite balanced, so let's try to get something a little closer to 9. We're probably going to have to, because we have 9 oxygens over here on the right hand side, and we're probably going to have to overshoot the oxygens because when we add something over on the product side, we're going to have more oxygens. So,
Well,
huh?
like put a 6 in front of it. Or a 4.
Okay, let's try 4. So that means 4 here, 4 here, and 12 here. That's probably a little bit more doable since we're wanting to overshoot the oxygens a little bit. So let's try to get the nitrogens balanced.
Put a 2 in front of the guys.
Okay, so put a 2 in front of NO2, and that makes that we have 4 there, and now how many oxygens do we have?
Wait.
4, 5, 6, 7, 8, 9, 10, 11.
6 plus 4 is 10, 11.
Don't you have 6 nitrogens?
No, you
What about that one?
We have 2 in the copper 2 nitrate and 2 in nitrogen dioxide. Okay, so I think we're getting close. Now the only thing that's not balanced is the water and the oxygen.
Put a 2 in front of water.
Okay, put a 2 in front of water, and now, voila, it's balanced.
What?
oh my gosh.
It was that easy.
What? Wait,
I'm over here
how'd you
like
get 12?
18 oxygen, 17 oxygen.
With the nitrate, we have 6. In the nitrate, on the product side, we have 6 oxygens. In the water, there's an additional 2, so that's 8. And then in the nitrogen dioxide, there's 4. So that's 12.
Can we make them not
The
this
200
hard on
pound
the
of water
test?
bumped it up from 11 to 12.
Yes.
Yeah, I'm not.
All right, so now let's just do the math.
Why was it so much?
Is there like a strategy to that?
Well, what do we do first? We're trying to get we try to balance first the nitrogens, the hydrogens, and then we needed to overshoot the oxygens on the reactant side. Because we knew we were going to have to multiply this, the products by a certain number so we get higher oxygen. So that's what we were trying to do. All right, so we're starting off with 0.45 moles of copper. And there's 1 mole of copper for every 4 moles of nitric acid.
May I have your attention, please? A representative from Barton College will be at NRCA today at 9 o'clock. Please come to Ms. Monahan's office if you are interested in learning more about Barton College. The proverb for today is Proverbs 11:21. Be assured, the evil person will not go unpunished, but the offspring of the righteous will be delivered. Thank you. Have a great day.
What's up with the verses?
It's so random.
All right, so this is 113.4 grams, and we need how many significant digits? 2. So 1.1 times 10 squared grams of nitric acid, or 110 grams of nitric acid, is a way to solve that. The correct number of significant digits. All right, so because the time is running short, let's go ahead and take a look at the last one. This one is hydrogen reacting with oxygen. Both of those are diatomic to form water, and that's balanced. We need to find the volume of oxygen, so we start off with 250 milliliters of hydrogen. That has to be converted into liters. There are 1,000 milliliters of hydrogen and 1 liter of hydrogen. And then we got to go to moles, so 22.4 liters of hydrogen is in 1 mole of hydrogen. And there's 2 moles of hydrogen for every 1 mole of oxygen. And then 1 mole of oxygen is 22.4 liters. So canceling out units that we we're left with liters of oxygen, and that's what we're trying to find, is the volume of oxygen.
0.125 liters of O2.
So 250 divided by 1,000.
No, 250 times 22.4.
Actually, the 22.4s cancel out.
Oh, yeah?
Yep.
Oh, I figured.
So 0.250 divided by 2 is 0.125 liters of oxygen, and we need 2 significant digits, so this is rounded to 0.13 liters
Wait, I don't think
of oxygen, because 250 has 2.
So like, okay. Is that the only conversion we'll have to know, the milliliters and liters for the test, you think?
Yeah.
Okay.
All right. Any other questions on those?
We had a blonde woman on.
You may keep your quizzes.